Today let's talk about the queue data structure. In the previous lecture we already discussed about the stack, and today we are going to learn about what is meant by queue, the basic introduction of queue, then the representation of queue in a memory and the types of queue. So let's start from the basic concept of queue, that what is meant by queue. It is a linear type of data structure. Queue is called as a linear data structure. What is meant by linear? The elements are stored in a sequential order. The elements are stored sequentially, that's why it is called as a linear data structure. Now the next important thing about queue is it follows FIFO principle. FIFO means first in, first out. Or we can also call it as a FCFS. FCFS means first come, first serve. Okay, you both are the same things. You can call queue as a FIFO, that means first in first out, or FCFS means first come first serve. What is the meaning of that? First in first out means the element which is inserted first will come out first. The element which is inserted first will be removed first. That's why it is called as a FIFO. Or we can also say that the element which is inserted last will be removed last. So these are the basic two important things about queue. Firstly, it is a linear data structure because all the elements stored sequentially. And the second one is it follows the FIFO principle, means the element which is inserted first will removed first. If we see the real life example of queue, then it can be a single lane one-way road where the vehicles which enter first will exit first. Okay, there is a one-way single lane road and where the vehicles which enter first will exit first. Or the second example we can say about queue is the queue of people waiting at railway station to get a ticket. Each new person who will come joins at the end of the queue and the person who comes first gets the ticket first. There is a ticket counter at railway station and there is a queue of people who are waiting to get the ticket. And the new person, each new person who will comes joins at the end of the queue and the person who comes first gets the ticket first. So remember these two examples, real life examples of queue. Sometimes it is asked in your exam also, so you have to remember the at least one of the real example of queue. Now let's see the implementation of queue. This is a representation of queue like this. Queue is represented like this and queue has, as you can see, queue has two open ends. The first end is called as a front and the second one is called as a rear. You can simply write down here F and R. The front is also called as a head and rear is also called as a tail. You can use either front and rear or head and tail. You cannot use front or tail and head or rear. If we use here front end, then the other end is rear, and if one end is head, then the other end is tail. So here queue has two open ends, one is called as a front and the second one is rear, or we can say that one is head and second one is tail. You can also represent it like single F and R. So here front and rear are the pointers. Okay, F and R are the pointers which points to the front and rear element of the queue. Here insertion of elements can be done from the rear end. Insertion of elements can be done from rear end and removal of elements are done from the front end. If we want to insert element, then we can insert it from the rear end, and if we want to remove element, then remove it from the front end. So insertion operation is also called as a NQ. Inserting element into the queue is called as a NQ, and removing element or deleting element from the queue is called as a DQ. These are the two important operations of queue data structure. So this is a simple implementation of queue. Let's revise it once again. This is a memory representation, or we can say that implementation of queue. Queue has two open ends. One is a front and second one is a rear, or we can say that one is head and second one is tail. Insertion of elements can be done from the rear end and removal of elements are done from the front end. So this is a basic concept about the queue. Now let's see the example of queue. Let's consider we have an array of 5 elements. For example, integer a of 5. We have an array of 5 elements of type integer and the name of array is a. Now we have array elements like 10, 20, 30, 40 and 50. Okay. So we have 5 elements and we have to insert all these elements into the queue. Now first of all, our queue is empty. Okay, when we consider queue as empty, when both the front and rear pointers are equal to 0, then we consider our queue as empty. In a stack, when the value of top is equal to -1, then we can say that our stack is empty. But here queue has two opponents, one is the front and the second one is rear. And if both the pointers value, that is front and rear, equal to 0, then we can say that our queue is empty. So right now our queue is empty and we are going to insert elements sequentially one by one. Okay, so first element we have to insert is 10. So here is a queue and we insert first element into the queue, that is 10. We already discussed about the front and rear pointers. If we want to insert element into the queue, so the insertion can be performed from the rear end and removal can be performed from the front end. So right now the value of front and rear is equal to 0. When we insert an element into the queue, then the rear pointer is incremented. Each time when we insert new element into the queue, then we increment the rear pointer. And when we remove element from the queue, then we increment the front pointer. Now we insert element 10 into the queue. Now our front and rear value is initially 0, that means our queue is empty, and we insert new element into the queue. So the rear value, the rear pointer is incremented by 1. Now rear has value 0, so it is incremented by 1. So rear is equal to 1. Now front has value 0, but front points to the first element of the queue and the first element of queue is 10. So the value of front is also incremented by 1. That means if front is equal to 0, then set front equal to 1 because front points to the first element of the queue. Now let's insert the second element, that is 20 into the queue. So first we have element 10 into the queue and insert 20. Now increment the rear pointer. So the value of rear is equal to rear plus 1, that means 2, and our front points to 1 because front points to the first element of the queue. Each time when we insert new element into the queue, the rear pointer is incremented by 1. And when we remove elements from the queue, then front pointer is incremented by 1. Now let's insert the third element into the queue and that is 30. So in queue we already have 10, 20. Now increment the rear pointer. So rear is equal to rear plus 1, that is 2 plus 1 is equal to 3. And here insert the third element, that is 30. And our front is again the first element of the queue and that is equal to 1. This is a rear. Okay. Now insert the fourth element, that is 40. Again in queue we have 10, 20, 30. Then the rear points to 3, that is 30. Increment the rear pointer by 1. So rear is equal to 4 and here insert the element, that is 40. Our front points to the same element, the first element of the queue, and that is equal to 1. Now again insert the last element of the queue, that is 50. So in queue we already have 10, 20, 30 and 40. And increment the rear pointer by 1. So rear is equal to 5 and here insert the new element, that is equal to 50. And front points to the first element of queue, that is equal to 1. So this is a insertion of elements into the queue. Each time when we insert new element into the queue, the rear pointer is incremented by 1. Now let's delete an element from the queue. We see the insertion of elements into the queue and now let's see how to delete elements from the queue. So as you know, queue has a property, that is FIFO principle. Queue follows FIFO principle, means the element which is inserted first will be removed first. So the element which is inserted first is in this queue is 10. So the element which is going to removed first is also 10. So here front equal to 1. So this element is deleted. Now front points to the second element. Front is incremented by 1. When we delete element from the queue, the first element of the queue, that is front equal to 1, then the front is incremented by 1. So now front value is equal to 2. So here again we delete the second element of the queue, again front is incremented by 1. So now front is equal to 3. Now our queue has elements 30, 40 and 50. Again we delete the front element of the queue. Again the front value is incremented by 1, that is equal to 4. Again we delete element from the queue. So again front value is incremented by 1. So front is equal to 5. Again we delete one element from the queue, the front element of the queue. Now our queue is empty. So front and rear equal to 0. So again front and rear is equal to 0 means our queue is empty, because we delete all the elements of the queue and right now our queue is empty. So this is the basic memory representation of queue. Now here we have to remember again two important terms related to queue. One is the overflow and the second one is underflow. Two terms are same as overflow and underflow in a stack. Okay, so both are same. In stack we already discussed about overflow and underflow, and the same concept applies to the queue. So what is meant by overflow? When a queue becomes full, that means the queue is overflow, and when the queue is empty, then we can call it as a queue underflow. Okay, so when the queue becomes full, that means the queue is overflow, then the insertion of elements cannot be performed and appropriate error message is returned. Okay, in the same way, when the queue is empty, that means it becomes underflow, and then the deletion operation cannot be performed and again the error message is written. So this is a basic concept of overflow and underflow. Remember once again, overflow means when the queue is full, then overflow condition will occur and we are not able to insert new element into the queue and returns the error message. And underflow means when the queue is empty, the underflow condition will occur and we are not able to remove element from the queue and the error message is written. Now let's see the types of queue. So there are 4 different types of queue. Here you have to remember only the names of queue. We can discuss each type of queue in a separate lecture. So there are 4 types of queue. The first one is a simple queue, or it is also called as a linear queue. Right now we discuss the implementation of simple queue, or we can say that linear queue. Okay. The second type of queue is circular queue. The third type of queue is priority queue. And the fourth type of queue is D queue. That means doubly ended queue. We discuss each type of queue in a separate lecture. You have to just remember the names of queue. So first one is a simple queue or linear queue. The second one is a circular queue. Third one is a priority queue. And fourth one is a D queue. That means doubly ended queue. Now here this D queue is different and this D queue is different. Okay, this D queue is an operation of queue which is used to remove elements from the queue, and this D queue is a type of queue also called as a doubly ended queue.